Go! Alright, so to review that last thing, if we wanted to find an equation that goes to 2 points, what do you need? You need a point and a vector, right? It goes through both points, so I don't care which point it is. I'm choosing 512 because it's closest. And then you need a vector that goes from 512 over to 822. So, you're famous now. So what vector goes from 512 to 822? How far is it from 5 to 8? 3. And how far is it from 12 to 22? 10. There it is. That's all it is. Gloriously easy. Another one. Goodbye. All right. So the next thing on our list of objectives is to try to figure out the angle made between 2 lines. It's easy though, right? Because math's easy. Okay. So yeah. So if you graph those lines, this is what they look like. There's the point they both go through, right there. So if I grab those and just put them over here in standard position, that's what they look like, right there. And I can connect those to make a triangle and use the law of cosines. Now some cute things happen with the law of cosines. We'll see if we can capture them without clunking it up too much. Okay. Wish me luck. Thanks. Let's call that x0, y0. Let's call that x1, y1. So those are those vectors. And let's call that, all right. Now how do you get from one point to the other? What do we do with the x's? Subtract them, right? So if I was like at 6 and I wanted to get to 8, that's 2 steps, 8 minus 6. That's going to be x1 minus x0, comma, y1 minus y0. y1 minus y0. This is where I'm going to find editing software, because I'm going to mess this up. Okay. We want this angle right here. Do you all remember the law of cosines? Do you?
Yes. C squared equals A squared plus B squared minus 2AC. No, 2A.
Good. Right. Nice. Okay, and what we really want is theta, so we could solve it for cosine C. I want to make that a theta this time so it matches my picture. So that would be C squared minus A squared minus B squared over negative 2AB. Okay? All right. Now, this is C over here. This is A over here. And this is B over here. So, A squared is the square root of x1 squared plus y1 squared. New student coming in. Distracted me. And b squared is x0 squared plus y0 squared. And what's c squared? It's x1 minus x0 squared plus y1 minus y0 squared. Okay? So, c squared is going to be x1 squared minus 2x1 x0 plus x0 squared plus y1 squared plus, minus 2y1 y0 plus y0 squared. And you don't have to write that down because it's forever on the interwebs, right? This is what we're going to do. We take all this mess, and it says we're supposed to subtract these things. Let's do it. X squared minus x1 squared, y1 squared minus y1 squared, that. I wrote a letter wrong someplace, but I don't care. Because I end up with minus 2 x 0. Okay? That's it. So, cosine theta is minus 2x0 x1 minus 2 y0 y1 over minus 2 AB. All right? See anything that'll go real quick? All those minus 2's. Yeah, don't write any of this down. No. Whoops. Okay. Now look at that pretty little pattern there. That's just two vectors. You multiply the first numbers together. You multiply the second numbers together, and you add them together. That is so often occurs in vector multiplications. It's got its own special name. That's called the dot product. That's important. You can tell it's important because it's written so big in the screen as a dot. The dot product. It's just a computation. It shows up a lot, so people just use special notation for it. They'll write U dot V. You had 3, 6 dot 2, 1. That would be 3 times 2 plus 6 times 1 is 12. Okay, that's the dot product. It's sometimes called the scalar product, because the things going in are vectors, but what comes out is a number. Lots of things. It's just a part of a computation. What does it tells us some things, it signifies some things. Its physical representation isn't much to speak of. We're almost done. Oh look, I got A and B. What are A and B?
Angle, sine, tangent.
That's like the length of a vector.
Inverse tan.
And that's the length of a vector. It's none of those things. It's the length of a vector.
Which is inverse tan.
And what's the notation for length of a vector? What was that called? It's the magnitude.
Magnitude.
Our book calls it the norm. And that's how you write the norm, right there. So those things are magnitudes. And so here's our fantastic formula for the angle between two vectors. You take the dot product, divided by the product of the norms, inverse cosine. So let's find the angle between these two vectors. Oh, I changed my example somewhere in the middle of the problem. That's obviously a positive too. Can you approximate that? What do you think? 15, 20 degrees? Let's see. So u dot v would be 2 times 3 plus 6 times 4. And the norm of u, the magnitude of u, Pythagorean theorem time, whoops, I knew the answer. I started writing 5. Okay, so our computation shows that's 18.43 degrees. Okay. Skip it. Oh, are those vectors perpendicular? What's perpendicular mean? They make a 90-degree angle. 90-degree angle. So 14 times negative 21 plus 22 times 15 over whoops, good, squared plus 15 squared. Now we don't really care what the angle is, right? We just want to know if it's 90 or not. Anybody know the cosine of 90 from when you had to memorize it?
0.
0. Ah. So what part of the formula's got to be 0 for them to be perpendicular? Top. Just the top. Ha! Okay? That sounds like a theorem. Okay, so this is a theorem. For some reason, with vectors, they use the word perpendicular. They also use the word orthogonal. If and only if the dot product is 0. That's handy. That turns out to be extraordinarily important. Is there?
For that kind of thing, can you convert them both to polar and add them?
Yeah, or you could multiply the x and multiply the y and add them together. It's a tremendous time saver. Yeah. Yeah, the flipping back and forth thing turns out to be a little bit irritating. So much round-off error involved, right? But if I can just go, are these perpendicular? Well, I got 14 times negative 21 plus 22 times 15. They feel like they're going to be close. I just got an extra button in my calculator. Times negative 21 plus 22 times 15. Nah, it didn't quite work. I'm off by a little bit. So no. Oh, look. So were they? No. All right. Those are the things we're going to do. We'll practice. That's all the juniors get, because I only got 10 seconds. We should do like acknowledgments. I'd like to thank the people who created the Smarter Balance test for giving me this opportunity.